All right, everyone. Since we're getting critical mass, wanted to go ahead and get things started officially. This is the next meeting of our OPI API work group. The topic for today we wanted to focus on was the first revision of the Cloud Protos. It's a pull request that's been put in related to getting the Cloud API prototypes, protobufs all updated and more or less pulled together. What we've started to get the initial comments, those have been going back and forth. Right now, it has not been merged yet. It's still an open API. So Vipin, if you wanted to go through it, I can turn it over to you. If you want me to share the screen, I can go ahead and do that. It's up to you.
Yeah. Thanks, Mark. Let me go over it. If I can share my screen, that would be good.
Sure, go right ahead.
Before we get started, I was trying to look for the raise hand button, but I don't see one on here.
It should be under reactions. I was just
reactions. Okay.
Yeah, making sure it was working. No problem.
Yeah, I was just wondering if I could add something quick to the agenda and maybe a 5-minute discussion up front before we do the big deep dive.
Sure.
So I know when I was digging through the GitHub early on, meeting notes were taken and added to GitHub, but we don't have meeting notes for a while. Is there, y'all probably discussed it, but maybe having like a Google Doc or something that, you could have like a continuation of meeting after meeting, where someone could add agenda items, ahead of time. I know sometimes we post it on Slack, but like this meeting, I didn't see anything posted. Have y'all discussed that a little bit more, or do y'all reject it up front, or?
So we kind of moved away from using Google Docs because it wasn't a common thing that everybody had access to. So that was one of the issues that we had around Google Docs. We could try and set that up again, or we could do something within the GitHub space if that will work in terms of doing that. We were originally keeping meeting notes, but we moved away from that when we started getting the cloud recordings. So everything was captured in the cloud recording that way.
Right, but then there's no summary or list of the cloud recordings. I mean, they're kind of scattered throughout the Slack, but they kind of go stale, and there's no summary of, well, here's the 4 topics of this cloud report or type of thing. So anyway, I was just curious if there was,
the recordings, Billy, what we're doing with recordings right now, and Paul Pendelli is helping us a lot with that. So we finally got a YouTube channel up and running. So he created the lists for all the subgroups, and we are uploading all the Zoom recordings from the Zoom cloud to YouTube. So hopefully we can put comments under each video as well to what this kind of recording is about. So at least it will help us organize a little bit more videos, but I hear your concern as well.
Yeah, Billy, we'll try to figure out.
Billy?
Yeah, we'll try to figure out something that we can do to keep track of the information, or at least the high level things that are covered in each meeting. So let me see if I can work on something for that.
Yeah, I mean, anything like that would be helpful. So just something to be able to go back and either find the list of recordings without having to go, through all the Slack, and or like a summary from each one. Just even if it's just a high level, here's the recording, but here are the 3 things we talked about, just so you have a reference and not just having to blindly go through all these recordings trying to find the topic or something.
Sure, no problem. It's a good idea. So let's try to. I'll try to see what I can do to organize something where we can do that.
Okay, thank you.
Okay, any other topics that we want to cover to the deep dive? All right, Vipin, I'll turn it over to you.
Thank you, Mark. Thanks everyone for reviewing the PR. Let me share my screen. Can you guys see it? Okay, so based on the last meeting, I did prepare some very preliminary analysis on, what can we do with Kubernetes offload, but maybe we'll not get time to go over that in this meeting today. So this PR consists of the object definition that was shared by Marcha in one of the previous meetings on how to get the basics going on. So intentionally there are functionality that could be very much applicable to cloud. It's not included here, especially HA and metering, policing, NATing, and all that. So we'll add that as an augmented thing. But at base level, this is describing how the network interfaces are exposed to tenants and realized on the DPU. I tried to capture all the explanation in the README here, which I'm sharing. You guys can see my screen, correct? Is it?
Yep, your screen is up, Vipin. Thank you.
And is the font size good, or should I make it bigger?
You might want to make it a little bit larger. I'm not sure how everybody else sees it.
Okay, how about this?
Yep, that looks good.
Okay, awesome. All right, so there's some generic description on how cloud sees networking as, and or cloud provider sees the networking as, and all. And there is a tenant view and cloud infrastructure view. Typically, tenants are configuring themselves under virtual private cloud, and each virtual private cloud has a bunch of networks, which is called subnets, and these subnets could have could be isolated, or they could be interconnected to other subnets, which is not very non-typical. In other words, they do actually talk to other subnets. But VPCs themselves can be completely isolated or talking to other VPCs as well. But that has to be explicitly configured. But basically, there are IP networks within a virtual private cloud. So think of that as maybe a bunch of subnets in your on-prem infrastructure. And a VPC has and routing provides traffic in and out of the VPC as well as to other VPCs. So in order to manage that, you do these things. Routes could be static as well as dynamic. So in the last discussion, I believe there were two things that were requested to be added, like we have support for static routes, and we also include the link layer configuration. So it is included, but from a tenant's point of view, it's a collection of IP networks and routes that describes how they could talk to each other. There is also network security policy that the tenant could configure, which is often called security groups in AWS terminology, and maybe some other things in different methods. There are things like how to peer with other VPCs, and maybe more advanced concepts like how to have a hybrid use case configured, wherein an on-prem device could have a connectivity to the cloud and all that. So again, those things are not covered, but they are also tenant level exposed to the user. So when a tenant configures these objects, ultimately cloud provider will take that and eventually provision that in the infrastructure. But this is what a tenant sees. So this is like the tip of the iceberg. There is a whole bunch of things going underneath, which is what I think DPU instantiates. Physically, the infrastructure looks something like you have a lot of bare metal servers on which you could instantiate VMs or containers, or bare metal itself be a unit of renting, if I were to call that renting a VM or renting a bare metal. And then they all through an XPU or DPU is somehow linked to the physical infrastructure. It's not somehow, I mean, an XPU has external facing ports, which is what connects to the network switch. And of course, there could be multiple ports for redundancy and all. I'm just showing one here. But the main point I'm trying to drive here is that most of the times, a tenant workload has a way to be identified in an XPU through an interface or through a VNIC object. So whether it's a pod, Kubernetes pod that is deployed in a native service. Native service means you could run Kubernetes inside the VMs that are entered in the cloud, but that will run its own control plane. That will run its own data plane in the cloud. So I'm not really referring to that, but maybe comparing it with AWS Fargate, which is really a native Kubernetes service. You only manage and run containers, in which case the CNI is completely managed by the cloud provider. But in native services, VM containers or bare metal will pretty much use the same infrastructure underneath. And they all are connected through this big giant mesh of cross networks of network switches, and then eventually interconnected with each other one way or the other. So now coming down to the meat of this PR, which is like, what are these objects really? Are these objects even relevant to, and then how are they relevant? So I try to keep this picture in the text form so other people who make changes to these can modify these quite natively. It's a little bit of work, but text is the simplest way probably. So I kept it as text pictures. So inside a bare metal node, even though cloud provider does not have access to the Ethernet devices inside the VM of any tenant, but these things are very important to be modeled inside the XPU, and therefore I'm just describing a VNIC object that effectively captures what a NetDev or Ethernet interface inside workload would look like. Now, when I use the term workload to say VM or a container or bare metal, and this is applicable to all three of them, but I'm using VM as an example here. So it would be an interface that pod is exposed with inside Kubernetes, or it could be interface a bare metal node could have that could be going into hypervisor, for example. And this is a tenant-owned hypervisor in that case. If bare metal is what cloud is renting, then but nevertheless, we need to identify what is the interface the guest VM or guest workload is exposing. That is VNIC object. VNIC object could be a physical function, or in case of bare metal, it will be a physical function. It could be a virtual function if through SRIOV bypass, these things are exposed natively inside the VM. Or they could be some kind of tagged interfaces using VLANs. You're identifying these interfaces. The goal of identifying these interfaces is to be able to know when these tentacles drop into XPU, which tenant they belong to, and or what kind of policies tenant is configuring on these interfaces that needs to be instantiated in XPU. So it's better to model that as VNIC object formally. These VNIC objects are typically not configured by tenant, but are instantiated by the cloud infrastructure based on how many, based on the fact that as these interfaces are as these workloads are created, typically these interfaces are part of the definition of a VM. For example, if you want to define a virtual machine definition in AWS, then you also say how many interfaces it will have. As part of that VM definition, and when a VM is orchestrated, or when you define a bare metal workload, when bare metal is instantiated, along with that workload, typically the network interface definition is included there. So as part of that, it gets instantiated. Of course, each of these interfaces will belong to a subnet. So we need to have a network object. This is the network that tenant is wanting this particular interface to belong to. So we have subnet object that defines that. There is another thing called mapping object, which is really the IP address and a MAC address of this interface. And it is important to identify every single IP address in cloud infrastructure that a tenant owns, because there is no IP that cloud infrastructure doesn't know, because clearly it cannot not only route to that traffic if it doesn't know it, but more importantly, it could be a security problem if all IP addresses which are owned by various tenants are not known to the cloud infrastructure. The difference between mapping object, which is also an interface IP and MAC, from a route object, is that route is a very generic prefix that you can have residing somewhere outside in the internet, like out here in this picture, or you could have routes to other VPCs. You could have routes to some services inside these things. So routes are a very generic object. Mapping identifies the IP address of the interfaces of workloads, really. So, and we'll look at the proto definitions to see what fields need to be different in these things. But basically, IP and MAC identification of these objects, that's the mapping object. An interface object is a generic definition of an interface that an XPU exposes. I'm showing here the physical interface that is exposed to the VM. So this could be a PF interface that identifies a physical function. But ultimately, an interface object is going to The interface could be a loopback interface on which you are running control protocol on XPU. It could be a control interface on which you want to run the orchestration, an orchestration entity to talk to DPU. Of course, it could be OOB management interface. The interface object captures all these kind of IP interfaces on XPU, including the ones that are facing tenants or something which is instantiated within. I'm calling. Yeah, sorry, go ahead, please.
Yeah, let me go ahead and ask a question, Vipin, because I know last meeting we were talking about OpenConfig to some extent. And OpenConfig defines an interface more like the port object, whereas this defines an interface as the exposed capability of the XPU toward the host.
No. Interfaces. Think of interface as I would say, Mark, interface is really an L3 configuration on an XPU. So it could be facing host. It could be something that is a control interface on which an orchestration entity is talking to XPU, in-band or out-of-band. So out-of-band is a typical OOB management interface on XPU, and in-band is something which could be an orchestration entity talking inline on the wire on this physical link to talk to XPU or from over the network. So you need to configure an IP interface on XPU to be able to have someone else, let's say a controller sitting here, to talk to XPU from over the network. So that is an interface. A loopback interface is another way of defining an interface. So an interface really is a layer 3 entity that is either facing host or for control plane purposes within an XPU. So interface is instantiated within XPU. It could be a PF. Yes, you're right. It could be a PF, but it doesn't have to be only that.
Okay. No, I'm just trying to think ahead because I didn't know if anybody was going to ask questions around the OpenConfig.
Absolutely, I think
we were talking last week. So
correct. No, the idea is that now that this is in black and white, I think people can compare now. I'm not saying that this definition has to be the only definition, but now we have two things to compare, and we can say whether this definition aligns, and if so, how do we consolidate things?
Yep, agreed. Okay, thank you.
Awesome. So I'm calling device object is really global network configuration. It is not the global XPU configuration. There are a whole bunch of things that needs to be identified at a global level from an XPU point of view that goes into device object. VNIC object, I think I responded to most of the comments from Tim, and he was asking like, why is VNIC object appearing twice? It's just that, I'm describing as in the pipeline, you're identifying this particular tentacle, which is coming into XPU as VNIC. And then you're associating that with a VPC, because the first thing that happens is VPC identification and the tenant identification as soon as traffic comes in, because XP is going to have a lot of these tentacles coming in from different workloads on the same XPU, and it must identify the tenant as the first thing, because then only it can allow to have that tenant context and the isolation that is needed to be provided. So VNIC object is going to help identify those things in the XPU here in this pipeline, and VPC object is going to define like what that VPC is, what the how VPC is identified on the wire and those kind of things. So VPC object is really what we were talking about in this definition, what a VPC is. So yeah, I think a typical pipeline would have a VPC identification and then a bunch of policies to be applied, and these could be not just network policies. For now, it is only network permit deny policy, which is captured in network policy.proto. But it could be NATing, it could be other services. You can think of metering and not other things, because metering is another thing that you would want to be done before it goes deeper into the processing, because you don't want to consume resources and you want to limit your tenants to what they paid for. So if a tenant paid for 10 megabits per second or 100, let's say 1 gig link, then even though XPU can process things at 100 gig or 200 gig, you may want to limit what a tenant's interface can potentially do based on these definitions. So metering and other things are also needed for billing purposes, and also it's important that the rate limiting happens right at the beginning. So a bunch of network services could be applied here. Then you decide what to do with the packet, like where to forward it or drop. I mean, if it is dropped, then clearly it'll not go further. But if it needs to be forwarded, then where and how it needs to be forwarded. The routing table and route object, which really defines the routes to other VPCs and or to internet or to other workloads within the tenant or to other subnets within the VPC itself. So that's what the route object will define. There's a thing called next hop object, which really a route object points to, like what is my next hop? It could be a tunnel, it could be a local interface, it could be local interface as in some other interface on this VPC, or it could be an ECMP coming out of the XPU if you have multiple interfaces on XPU in order to achieve better load balancing through the network. These are fairly standard things in routing. As you can see, there is no layer 2 definition. Like you're not going to be able to send traffic out on a VLAN because most of the, or rather, every cloud infra that I've seen is all underlays, all layer 3. So so that's why I think just making this a route object. Ultimately, after routing, you will decide to either
just make sure you pause for people to ask questions. We want this to be as interactive as possible.
Yeah. I can pause now, or I was just going to cover 3 more objects and then we just open it up for everything. Yeah. Once routing is done, you tunnel the traffic depending on where it's going. So it could be inserting VPC ID into it and put another header on top of it, and then tunnel the traffic to other endpoint, other mapping within the VPC, across the VPC, and all that. There's a thing called CP route, and it's called control plane route. We can probably name it differently if this term is looking weird. But the main thing, this is really underlay routing, and we want to decouple the overlay routing, which route object defines, from the underlay routing. Underlay routing is different in the sense that overlay routing is very much dictated by the subnets and routes configured by tenants and or provisioned by tenants. But the underlay routes have their configuration coming from the cloud infrastructure itself. In the PRs, you will see the difference between underlay route versus an overlay route. And at some point, it looks tempting to basically combine these 2 objects and create an Uber object. But then I think in our experience, a lot of things are not applicable, like next hops of tunnels and all that is not applicable to control plane routes. And you will end up doing a lot more checks to not allow this and not allow that on these routes. So we ended up at least proposing that it's a separate route. And finally, after route lookup, it'll say that, okay, after tunneling, you will do outer route lookup, and outer route lookup will say, go out on this port with this MAC and then cap, and then goes to the network switch. So these are the objects. Most of these objects are now probably going to be somewhat self-explanatory. VPC, VNIC, tunnel, subnet, route, port, next hop, network policy, mapping, interface device, and CP route and BGP. Yep. So that covers static routing, covers link level configuration, it covers the routing control plane config, covers the network policy, and covers the base interfaces and all those things on the DPU. Any questions?
BGP stands out as being a bit odd in that list, simply because all the other things are actually programming a data plane, whereas BGP is a control plane process. What's the reason for including BGP?
Good point. So BGP exists for the underlay routing and not so much for the overlay, in the sense that BGP is not used for tenant routing tenant traffic, because that is typically done using the as the end controller of the cloud provider. But the reason to include BGP is just to have dynamic routing for these for the underlay traffic, or static routing as well. So the BGP proto really defines configuration of BGP daemon that is running for the underlay, and not defining the routing protocols themselves. Majority of the cloud providers use control plane to route underlay traffic, even though you might think that, why do I need BGP if in underlay I have 1 or 2 links, right? I mean, you need BGP in maybe more sophisticated things, but even with 1 or 2 links, it makes sense to not configure them statically. And let's say if there is 1 more link going to another network switch for redundancy purposes, then, and if this network switch dies, then this other network switch needs to draw all the routes from XPU towards itself, because technically this link could be up, but let's say this uplink switch dies, then BGP is better suited to attract traffic from the other link from XPU to rest of the network. So a cloud provider then in that case does not have to manually go and adjust these routes. So the moment you throw in redundancy and high availability, the routing protocol becomes almost a must-have. And therefore, what I consider BGP for underlay is a minimum, but because
Sorry, I'm not questioning whether or not we should use BGP for controlling the underlay.
okay.
I'm more just interested in the fact that the BGP routing daemon or agent is considered an integral part of the XPU pipeline.
Yeah, it will be integral part if you have BGP configuration, but you can have static routes and avoid control plane routing altogether. And if BGP is configured, then yes, I think it is assumed that BGP daemon is running inside XPU to talk to the network switches that is interconnecting to.
Does the BGP definition include measures to do VPNs, for example, to EVPN, L2 VPNs and L3 VPNs, so exposing that to the tenant overlay and having a backbone BGP to interconnect?
The answer is no. There is no EVPN used here because I think I was also mentioning that BGP is not used for tenant routing. Tenant routes are completely managed by the SDN controller. BGP is so EVPN use case really is for routing the workloads IP addresses across in the network, whereas BGP here is used only for the cloud underlay as a base to start bootstrapping the underlay routing so that it can start to route traffic for the tunnels themselves. Like once you tunnel the traffic, then where to route it. So to answer your question, no, it is not EVPN at all. It is a very basic, simple, very low scale BGP, which allows wildcard traffic to be redirected to various uplink ports from an XPU depending on the network conditions.
But speaking from a telco perspective, I'm coming from Ericsson. We have a clear need to have multiple networks, even exposed to the same tenant. And for that, one obvious possibility is to use the L2 and L3 VPN capabilities of EVPN. So for mapping the overlay to the underlay, it would be very feasible to be able to configure VIFs and VPNs, supporting VPNs. Yeah,
I concur with the use case you're bringing. I didn't catch your name, but I agree with you that EVPN is a great solution for telco in those use cases. Having said that, that's why I'm calling this to be cloud APIs, as in the multi-tenant cloud infrastructure APIs. For telco, I think doing EVPN to distribute MAC addresses and the route tables, both type 2 and type 5 routes through BGP, would be a very good solution there. And at the same time, not have to worry about where those things are. In cloud infrastructure, from my experience, no one uses EVPN to distribute tenant routes. They always have a SDN controller which knows the mapping object, which is really the endpoint IP addresses, and they distribute the route tables for various endpoints directly through the APIs to XPU.
But would you then envision that we have a different cloud for telco than to more classical virtual networks?
No. So let me back off a little bit. I think what I meant to say was that you can always have an EVPN control plane driving these APIs, even in this model. I don't think anyone is saying this is not possible. If you want to really build a multi-tenant cloud, I want to use EVPN control plane to drive the routing for tenant traffic, then absolutely it is possible to have either either a BGP instance doing overlay routing, whereby you can peer for an overlay EVPN network from these from these DPUs for overlay routing, so you don't need to use a very classic API based control plane there. But I've not included that in this use case because right now we started off with a very base set. And if we want to expand to use BGP for overlay routing as well, that would be an addition to what we already have on top of this. I'm assuming right now that someone is driving it through APIs, but if someone wants to use EVPN control plane to distribute tenant routes, then certainly it is possible. In which case, you would, in fact, to be very honest, here at AMD Pensando, we had implemented exactly what you're talking about. But I intentionally don't want to throw in so many things right now that we just want to create a base here to start off with. So yeah, I think it'll be a good thing for us to see how we can expand this to have the overlay routing or the tenant routing also be done via control plane protocol like BGP, and that would be done in that case, of course, EVPN.
Yeah, and I mean, EVPN is probably not the bigger. The important part is that we have the ability to have network separation, that it actually multiple networks domains that is covered, and not a single IP address space.
Yeah, overlapping subnets and all. Yes.
Yeah.
Just a quick moderation note. We want to be outcome driven. So eventually, as soon as possible, I want everybody to review this pull request, and we want to merge something, right? We've been talking about network APIs, and we've been presented it quite some time. This is a forum discussion that everybody can bring any questions and concerns that you want, but please bear in mind that I do want us to be outcome oriented. We do want those APIs or subset at least to be agreed on. So speak up, please, Marvell. I see you guys here. I see other companies. Please comment, ask your questions. If we agree on, if you disagree on some protobuf definitions, we can always remove it from this pull request and merge all the rest. But we do need to merge something soon. So I want us to have an open discussion. Everybody can agree. I want DPU vendor companies like Vipin, like Marvell, NVIDIA, Intel. I want you guys also to speak up and say whether you can actually implement those APIs, right? It's not enough for us to define those APIs. We need DPU vendors to actually say and prove that they can actually implement that. If that is easy and trivial, that's fine. If not, you need to speak up and raise questions. Go ahead.
Yeah, Prasad, go ahead.
Yeah, so I am providing comment on the patch itself. I can say for sure this patch is my previous one. The number of objects I have had to review is far lesser, even though the individual fields are still debatable. I'm trying to get the information sorted. At this point, I have like a couple of objections. One, if as a vendor, we're trying to implement this specification, I would like some flexibility on what parts are optional and what parts are not. So I think in that sense, I think we can have faster comments, and we do need some way to express a capability. As a vendor, I want to be able to declare this is what I actually support.
Sure.
The spec can be wider than what a vendor can support. That may be one way to do it, or we trim down big parts of it and only merge in what every vendor agrees on. I'm not sure we'll do the latter. So if we can create some capability for these objects, and we can agree on those capabilities, which ones need to be optional, I think we'll be able to merge this.
Makes sense. Prasad, a very good point in the sense that, look, as much as I try to be neutral, I do have bias and based on what I have seen. But at the same time, you guys have to keep me honest, and we should do that exercise. If you feel that this is sounding too specific, then please speak up, and we'll definitely make it optional and or find a ways to expose that by capabilities so that, as other vendors want to include it, they could, but they are not forced to.
Okay, thanks. And Boris, I think I had one question for you. Maybe if you have a couple of minutes, I would like to discuss that. So I am looking for the transition point from the lifecycle management to the API. This is important in terms of, I want to know what's the state of the device when the lifecycle management is completed, and what's the configuration that's going to come through. What is the first configuration information that I can expect to come through? So I want to know whether my IP address is already configured as part of lifecycle or not, in which case some of those things should not be in this API. Or if those are there, what do they do now? Are we changing the information that we are registering with the controller? I need to get that sorted. So you, I think, are there in both the forums. Maybe you can be the best judge of what is the state of the DPU when the first message comes, and how much of that is still fixed, like doesn't change via these API.
Yeah, that's a good question. Yeah, for sure. I just don't want to steal Vipin's time today, and
No,
we can
I'm-
definitely
yeah.
pick this up in the separate forum for sure. That's a good, excellent question.
So
Yeah,
I
those are
think
the broad concerns I
appreciate, and raising concerns is actually a very good thing, because these APIs, I could publish this API as a Pensando API if that's all the goal is, but that's not the goal. I mean, if you want changes, please definitely speak up, and we'll make whatever it makes to these APIs to be more OPI APIs and not Pensando APIs. This is just an initial proposal. This is V1 alpha, so there is a lot of room for leeway into changing it without promise of breaking anyone's software layers and all that. So comments are really appreciated. I'll try to respond to those as soon as I can. And even if you feel that in many cases it is becoming too much to describe it, you can subsequently submit another PR to make that change on top of this. So I'll leave it at that, and encourage everyone to provide comments. Anything else, Boris, Mark? You want to add?
Richard has a
Richard,
comment.
yeah.
Yeah, sure.
Okay. I have a question. How do the IPU handle the ARP or ND reply? In general, in Tesla we use the terminal, but for the ARP or ND, we suppose the IPU or DPU can reply the request automatically. So I do not see in the actually I don't see anything report about the neighbor or something like that.
Yeah, so Richard, I think your question is, so there is ARP and ND for these workloads, and there is ARP and ND for the management interfaces on XPU itself. So I'll break the answer into two parts. If you have, for underlay itself, you need to resolve an IP address and all that. So I'm assuming that the Linux stack running on XPU takes care of that in a standard way. I did not, for example, intentionally include the DHCP proto into this one, because it was, again, can we look at those things later on. For now, I'm assuming that however XPU gets an IP interface through ARP and DHCP does it like how Linux does it. This is for the underlay again. Underlay as in the cloud infrastructure IP network on which is not the tenant DHCP, but a VM. Are you referring to?
I mean the overlay.
Oh yeah, okay, overlay. So for overlay, it is possible to because if you see the VPC proto and if you see the subnet proto, there is something called virtual IP. So virtual IP as in the subnet's router IP. So a VM in this bare metal node and another VM in another bare metal node could belong to the same subnet, and we are not bridging traffic in between these guys. Clearly, we are routing it. So there's a concept of virtual router, in which case, or what are the gateway IP? Gateway IP is going to be, mimicked by XPUs across all XPUs on behalf of that subnet, and an XPU is going to respond to the ARP with the gateway IP, with the gateway IP's MAC. So in that case, that is that is what is going to help emulate the distributed subnet across multiple switches in this environment. So in short, to answer your question, there is no configuration needed for that. It's a processing detail. You have to respond to ARP, but the only configuration I see is if we go to subnet proto, there is something called the gateway IP.
No, I mean, don't mean great IP. I mean that, for example, there are two VM that in two bare metal servers. So
yeah,
in the communication, our two IPs, it will need the neighbor. So there are ERP requests, right? In our but in VXLAN, it do have level 2 forwarding, but in my opinion, this is not best practice. So in general, we use in the SLANIC, for example, in the SLANIC scenario, we'll use SLANIC to auto reply the ERP request in the same bare metal. Do not forwarding the ERP request to all bare metal.
Yeah, you're correct. You're correct. That's what I was also expecting happens here. If an ARP request comes from a tenant on this node, it is not going to be relayed to another node. This entity, or rather the XPU on behalf of a subnet, is going to respond to the ARP right there from the XPU itself. The point I was saying, Richard, was that this is more of a functional behavior which we should capture, but from configuration point of view, I wasn't thinking that there is a knob that we need to expose. So that's why you don't see something very explicit in this PR. But you're absolutely correct. We need to have that functional definition on what goes on into this pipeline with respect to not just the data packets, but also ARP, DHCP, and DNS, packets which is going to come from tenant and needs to be intercepted by XPU. I did not include it in this description because, again, this is supposed to be just the configuration specific things as of now, not the behavioral thing. But when we implement a reference model, that's when I think we will discuss these things as to how this behavior works. Remember, we talked about having a reference model for these APIs so that people can understand the behavior against these proto definitions. So we haven't really had deeper discussion on the reference model, but it would really belong into that discussion, and we will certainly. But what you're saying is exactly what should happen, in my opinion. But we will discuss on whatever we think is the right way of responding to not just ours, but DHCP and other things too.
Oh, okay. Thank you.
Yeah.
No question for Vipin. We discussed that APIs shouldn't be without any reference or example implementations, right? So we're thinking at some point that we can run DPDK and then use those APIs and translate them from protobuf gRPC to DPDK and show the use case that you show here. Using the DPDK as an example open source project before we have real hardware and showing that the real hardware. Is that still kind of plan? I'm just wondering.
Yeah, I mean, that is the plan. I had mentioned earlier that we want to have reference implementation regardless of any DPU vendor, which is a software only implementation that could be that doesn't use any of the hooks or anything that any of the vendors offer, but it also serves clarification on things like what Richard was asking, and there are a lot more things to be done there. The main impediment I see to getting there is getting onto it. If we wait for reference implementation, certainly we can hold on to this PR and get the reference implementation up and running alongside this PR, or we could start to put the proto definitions and then see where the commonalities are across various things and domains and all that, and in parallel work on the reference implementation. I'm happy to contribute with whoever is interested on the reference implementation. So let's collaborate offline on trying to get that reference implementation up and running. Either way, I think it is needed, whether now or later, whether we hold on to this PR or not, doesn't really matter. We need a reference implementation. And it could be DPDK based, but I don't think we have formally discussed that. What is the right choice to do it? I'm good with having a DPDK based reference implementation, but I would like to see what others would want. So maybe a separate meeting on how the reference implementation should be. How can we do it in a way we could run most of the test cases on this proto definitions without needing any physical hardware, those kind of things. Definitely a separate meeting, but I would like to hear what are others' opinion on having that implementation vis-a-vis the proto definitions.
Thanks, Vipin. Donald, do you have a comment?
Okay, any other comments or questions?
I have a question to Marvell, back to Marvell, Prasad and others. Do you think that those APIs can be implemented by Marvell? Does it make sense? Do you see any rejections, immediate kind of thinking? Are there any proto files that you want us to remove or fields to make optional so Marvell can easily implement that? What is your initial thought after reviewing it?
Yeah, I mean, as I said, the number of objects are far fewer. Some files that we may take longer to converge on and maybe are not immediately needed. I think BGP is one of them. I don't think it's needed right now. We can set up a configuration without BGP, I think. I'm not sure network policy is an urgent requirement either. So those two stand out for me. I'm just looking at the interconnects between some of the others to see what's actually required. But
would those just be optional, Prasad? Is that what you're looking at it from the standpoint of those being optional, or was it something you wanted removed?
So for us to merge, so if somebody else wants to implement BGP, that's fine. But for me to review and agree on, I think we'll just be going on a tangent that's not needed for this patch, is my thought. So there are two ways to do it. So we can merge it without any further review from Marvell side. I will not have an objection to say don't merge BGP but I do want it to be optional at a minimum, so that as a vendor I can be compliant with the API without having to implement parts of it.
Yeah, Prasad, I think I concur with your comment, and that's why we have added static routing into this PR based on your comment last time. So at least static route is the base, and if you want dynamic routing, you can. Otherwise, it should be okay to keep BGP out for now and then add it later. I included because I feel I've never seen an implementation that doesn't use one in cloud deployment, but some people might consider this as a base. And so the definition of what is base is relative based on what user would want. But from implementation's point of view, if you think that, clearly network policy also I included because it was requested in the last meeting, like let's have this as a base subset. But network policy is completely optional. It also gives a flavor of where the policies and services will fit in the pipeline, just so we can ideate around that. But your comment is apt on BGP. It's not a must-have. You can perfectly do it with static routing quite well, and especially if you don't have very elaborate, large underlay network, then why would you want that? And baby steps. Even if you want BGP, why introduce that right now until we get traffic to be forwarded? Just as this for now, and then introduce the dynamic routing later.
So maybe to turn around the question a little bit, if we take Dell as an example, or HPE, they would join next week, I guess, and there would be other consumers. Who do you think will consume these APIs? That's part of OPI right now. I mean, if the DPU vendors or XPU vendors had something like this implemented, do you have a line of sight for how consumable these are? Or are these purely meant for hyperscaler cloud providers kind of consumers who are not in the room right now?
So, Prasad, I can try and talk to some people I'm working with to come and describe their opinion if that's where you're going, because they will be the users, in my opinion. The users need not be hyperscalers. They could be anyone who is willing to offer, small to medium sized cloud infrastructure to their tenants. And when I say small, it's relative compared to hyperscaler. Someone with maybe 100,000 server cloud is also considered small. And I won't name vendors right now, or cloud vendors. I mean, there are many tier 2 cloud vendors that this is applicable to as well. So now, if someone wants to stand up a private cloud, which looks pretty much like a multi-tenant public cloud, then yeah, sure. In spirit, this is exactly same use case. So if we are talking about getting users on board with this, I'm happy to reach out to some of the people who are using these APIs to see if they're interested in coming to OPI.
Right. From a very practical standpoint, and right, we can, if we have to assign engineering resources to do something,
Mhm.
I think there's great value in participating in open source projects like OPI and contributing and helping standards evolve. And then there's the second aspect of, can we fund an internal project to actually implement certain APIs as part of our product offering, right? And we'll say, okay, we'll bake this into the software that our company provides to all our customers. For the latter to happen, there has to be a clearer line of sight. So I think before it's a question of would Marvell implement it, the question for me is, why would Marvell implement it right now, right? I mean, as our participation in the standards body, I mean, for things like lifecycle management and the storage APIs, I mean, we have a clear path to, we have to implement something like that internally for all our customers. And wouldn't it be perfect if we implemented something that's an industry standard? And wouldn't it be even better if we contributed to creation of that industry standard? So there, I think there's more clarity on what would be the justification for us to assign engineering resources to do this implementation. For this particular aspect, I think I still am a little fuzzy on. So I don't have an objection to the contribution, but I'm just responding to Boris's question of, would Marvell implement it? I mean, for me, the question is, why would Marvell implement this at this point of time? Unless we hear directly from the consumers or potential consumers of these APIs, and you can say, okay, this is something that can have wider applicability.
Fair point. I mean, business case always presides. If there is no business case, then why would you dedicate engineering resources to it? My point was to actually address that very gut of your question by saying that, what if a consumer of this API comes and describes that this is their use case? If you implement it, then they will look at this as a generic API across DPU vendors that they could switch to. If that appeals, then yeah, sure, you could consider implementing it. If that doesn't appeal, or maybe you still have to evaluate if there is a business case for you or not, and that is outside this forum for sure. But ultimately, people need to look at it from if this is an appealing use case that they want to go after from the overall point of view, and if it is, then it's worth looking at homogenizing these APIs for some of the users who are looking for this.
I agree. I think some of the insights from the potential users that you mentioned, I mean, if you can have them come talk to us, I think that would certainly be helpful.
Sure.
Us being the OPI forum, of course.
Prasad, you've got your hand raised.
Yeah, I mean, I think the point that Boris and Prasad made got me just thinking. So, I mean, if Marvell did implement it, would you folks like Dell, HP, Tencent, all of you guys are part of this? Would you guys actually try it out? Get back to vendors? Is that a possibility? Is that something you guys would do? Maybe we would have to look outside, right?
We would. Yeah, from a Dell perspective, yes, we would.
Yeah, I just had a simple
And
question.
try-
with that.
Well, so, and I would make a stronger statement publicly, more than try it out. Use it.
Yep.
We have use cases that would apply, although again, we have to, again, we start to stray into interesting territory because we can't really talk about product plans, but the whole point of this is this job, so we need to bring this back to the TSC yet again, because it goes with the TSC call we had earlier this morning. It dovetails to that call. And this is something we have to sort out just the way you guys are describing it. So I've been following the discussion with interest.
That's really good to know, Joe.
Thank you, John. Well, I think that's all I had on this PR. Mark, we will cover the Kubernetes discussion next week. I was ready with some pointers to various things, but we could do that later. There's no rush. Let's just try to nail down the use case. And Kubernetes use case, as we go through that, we'll see how different that is. And then that is its own world of things.
Yep, I put it on there for a topic for next week's discussion. And I will also work on putting together a notes and recordings pointer that Billy pointed out. So we'll try to figure out how to feed that into the GitHub location. As of that, we've got about a minute left, so I will wrap things up for today and we'll meet again next week. Thanks for attending, everybody, and Vipin, thank you for going through the PR.
Yeah, appreciate all the feedback, guys. Thanks.
All right, thank you.
Bye.
Bye-bye.